Alright, some of my parts came in. Still waiting on a few other wire end connectors and stuff. Of course, the DC to DC battery charger slash MPPT charge controller, solar. You got the MC4 connectors for your input from a solar panel, 12 volt anyway, rated. And I went ahead and connected these with these temporary or screw-on sort of bus type connectors to be able to put a fuse link and wire. It'll come from my little 30 amp AC to DC converter or power supply. So of course it plugs into the wall. In this case, my extension cord. I'll plug into this. Will simulate a vehicle's charging system because it's a variable voltage power supply, so I can crank it up to 15 volts if needed, but I can keep it down around 13.5 to 14, have it feed into of course the charge controller, which will then charge the battery, which from here, and yes, I got these screw-on, let's see what they call them, offset tongue lugs to be able to use, so I can just screw the wires on, clamp them on, instead of using a separate connector to crimp in case I have to change the configuration again. So I like to save that wire if I can, because some of this 8 gauge, I know it's hard not focusing on the end of it there, 8 gauge solid copper is not cheap. So use that to go into the 10 gauge, and then of course all my wires for doing that, or from remnant wires from my old subwoofer system in my van that I got rid of. Transmission crapped out twice. And then of course we'll be going from the battery to this 8 to 40 volt input capable, and output stays as steady 13.8, 25 amp, or up to close to 345 watts max converter. So it's a boost buck converter. I'll go to these terminals so I can come off of this type of power supply to other components such as CB radio, maybe a linear amp here. That's 100 watt on AM and 200 watt on single sideband, up to, that is. But those type of components want that 13.8 volts. They don't, those components really don't like being undervolted or overvolted. You can burn up components in them. Overvolting could probably overdrive your main driving transistors in the radio or amp, and then undervolting can also mess up some of the capacitors when they're wanting to see that close to average of 13.8 volts, which is similar to what a car puts out in its electrical system, 12 volt system. When the car's turned on and running, it's what the alternator's putting out. So you want that 13.8 volts to give these components, if you're setting up a base station, not a car in your car, you want that to be able to have the voltage it wants. Because I already had one little linear amp over time, just leaving it on, even under receive, and next thing I know, a couple transmits, and boom. It didn't like it. It didn't burn up in smoke or anything, but a friend of mine found out that if you capacitors in there burn up, and it's probably not from being overdriven. It's been undervolted on power for too long. So while these lithium batteries, their top voltage when fully charged before it shuts off, the BMS shuts off charging mode, 14.6 volts, but it can go as low as 10 volts on the low end before it shuts off from over discharge. So you want a constant voltage for powering components. And then to be able to keep this powered, I'll have the charge controller being powered by this, at least at first. And if total power goes out, I need to be able to continue charge on the battery. Then I can use a small portable fold-out solar panel that will help it at least stay charged. I'm not going to be transmitting much, so it'll definitely be charging more than what the draw is when just monitoring radio frequencies on this radio, and another one that has a built-in scanner. So it's going to be my DC driven instead of alternate current. It'll be my direct current, basically 12 volt rated uninterrupted power supply. So power goes out, get nothing from here, then we still have fallback here, and it's not going to pull from here to there like it would in the vehicle, or if there's solar panels hooked up, it's not going to push back to here because you got 0 volts. It'll only start charging over here to a start battery on RV setup if it has 2+ volts. With it having no power, it goes to 0 volts. It's not going to be trying to push current back into this power supply. So this is what I'm looking. No power from the grid goes down, then this has been charging the battery. I'll have power off the battery to be able to power these and also other USB devices. Now, to be able to know voltages on everything from this guy to what this is putting out to the battery, and so it'll be off the battery, basically, voltage off the battery, then voltage off of the power distribution at 13.8, and make sure I have a little USB, and it's like for putting on cars or boats and stuff. It's an actual panel with a cigarette lighter adapter type power plug and a rocker on-off switch. Well, it shows the voltage on the USB charger on that, so I'll be able to charge other USB devices. And also with the 2 other voltmeters I'm getting, like I said, I'll see what the voltage is at the battery, which means off of this, sometimes I'll be able to know where the battery sits on voltage. And of course, I want to maintain that my setting on this doesn't vary from where I set it. So all this is going to be coming together soon. Just want to give you a little heads up, a little preview of some of the stuff to be worked on, and we'll get to it soon as those other parts get in.